Today you're doing 7.6, which is similar figures. The first definition we need to get down is similar. And similar means to have the same shape, but not necessarily the same size. So if you look up here at this table, we have all the same A's, which is the same shape, but none of them are the same size. But they are similar figures. If you look up here at the top, you'll notice a pattern. They're always doubling. So 1 doubles to 2, which doubles to 4, which doubles to 6. And it's the same thing. 12 doubles to 24, which doubles to 48, which doubles to 72. So they are similar figures. So for the majority of this lesson, we are going to be looking at polygons. And there are two things that we need to have down. So for polygons, you must have a corresponding angle that must be congruent. And remember, congruent means the same size. Then also you have to have corresponding sides must have lengths that form equivalent ratios. So they must be in proportion. So let's start with this first example. It says a picture 4 inches tall and 9 inches wide is to be scaled to 2.5 inches tall to be displayed on a web page. How wide should the picture be on the web page for the two pictures to be similar? So what I do is I always start by drawing a picture. So I know that I'm given a picture that's 4 inches tall and 9 inches wide. And we're scaling it down so that it's going to be 2.5 inches tall. And then it says how wide. So this part is unknown. So we can put a variable in there for x. So since they're similar, we know that they are in proportion. So we can create a proportion. So what I'm going to do is I'm going to do 4 over 9. So I'm doing tall over width. And I'm going to say that equals my second one. So I have to do tall again. So 2.5 over x. Now you totally could have flip-flopped these two if you wanted. So now, just like we did before, I'm going to cross multiply. So I get 4x equals 9 times 2.5. So I'm going to rewrite this as 4x equals 22.5. I'm going to divide by 4 on both sides. So x equals 5.625, and we need to include our unit of inches. So that right there is your answer. Let's try another one. It says a company's logo is in the shape of an isosceles triangle with two sides that are each 2.4 inches long and one side that is 1.8 inches long. At a billboard, the triangle in the logo has two sides that are each 8 feet long. What is the length of the third side of the triangle on the billboard? So again, I'm going to start by drawing a picture. It's an isosceles, so it says two sides are 2.4 inches long. So I know that both of these sides are 2.4 inches, and one side is 1.8 inches. And they want us to create another triangle. This one's actually going to be bigger this time, that has two sides that are 8 feet long. So these are both going to be 8 feet. And this side is our unknown, so I'm going to put it in x because it's asking what is the length. So again, I'm going to create a proportion. So I'm going to do 2.4 over 1.8. And again, if you want, you can have these two flip-flopped. But since I'm starting with the equal side length, that means I have to have 8 on top because those correspond to each other. And I'm going to have x on the bottom because that corresponds with 1.8. So now I just need to solve. So I'm going to cross multiply. So I get 2.4x equals 1.8 times 8. So 2.4x equals 14.4. Divide by 2.4. So x equals 6 feet long. Here's our last example, and it's asking us to find which rectangles are similar. So we need to start with two proportions because we know that two ratios create a proportion. So I'm first going to start by comparing to see if A equals B. So what I'm going to do is I'm going to create a ratio. I'm going to start with the 2 over 3. Now if I start with this, I have to figure out which side corresponds in B. And that would be 3. So I'm going to do 3 over 4. Now we've learned 2 ways to find if they are in proportion. You can cross multiply. So we can say that 8 equals 9, which is not true. So we know that this is not in proportion. Or you can see that these are both in simplest form and that they're not equal, so therefore it's not a proportion. So we need to try another one because A and B are not similar. So let's try A and C. So I'm going to start again. 2 over 3 equals 4 over 6. So I'm going to cross multiply. So 2 times 6 is 12 equals 3 times 4, which is also 12. So therefore, which rectangles are similar? We're going to say A and C because those ones are in proportion. So at this point, you can now do your exit slip.